Page 7 of probability. Problem 3, we're going to do A, C, and E. A small hotel in London has kept a record of all the room bookings made for the year, characterized by season and booking type. Find the probability that a random selected booking was in the peak season, single or double room, in the peak season, given that it was not a single room. Okay, so again, like we did before, it would be good to get these totals because we're going to need the totals. So let's do the total of 125 plus 48, or 248. That gives us 373. 220 plus 192, 412. 98 plus 152, 250. 125 plus 220 plus 98, 443. Let's rewrite that. 443. 248 plus 192 plus 152, 592. Let's get the grand total. 1,035 is the total. Okay. So, what is the probability that a random selected booking was in the peak season? Peak season is here. So it would be 443 divided by 1,035, which is the grand total. Okay? C, probability that it's in a single or a double room. So that would be 373 plus 412, which would be 785. And we're going to divide it by the grand total, 1,035. E, in the peak season, given that it was not a single room. Okay, so this time we're going to look at not a single room, which is here, and we want the peak season given that it was not in a single room. So that would be peak season in not a single room is 220 plus 98, because those are the totals for double and family, and then we're going to divide that by all of the double and family, which would be 412 plus 250. So we'll total these up. 220 plus 98 is 318, and then 412 plus 250 is 662. 250. Okay, so that was E. 22E, compound events. Independent events do not affect each other's probability. In this case, you can find the probability that two events occur with multiplication. So if you want the probability that A and B occur, you could find it with probability of A times the probability of B. This also works for three or more events. For example, you could have probability that A, B, and C all occur. You could say probability of A times probability of B times probability of C. 22E.1 all. At the mountain village in Papua New Guinea, it rains on average 6 days a week. Determine the probability that it rains on any one day. Okay, so since it rains 6 days a week, that means that it rains 6 days in 7. So what are the chances that it's going to rain in one day? It would be 6 over 7. What about 2 successive days? So that would be 6 times 7 times 6 times 7, which would be 36 divided by 49. What about 3 successive days? That would be 6 times 7 times 6 times 7 times 6 times 7, which you could write 6 times 7 cubed. That would be 6 times 6 times 6 divided by 7 divided by 7 divided by 7. It would be 0.62 0.630. Okay, last one is 0. All right. 3. A school has 2 photocopiers. On any one day, machine A has an 8% chance of malfunctioning. Machine B has a 12% chance of malfunctioning. Sounds like EAC. Determine the probability that on any one day both machines will malfunction. Okay. Any one day both machines will malfunction. So that means that machine A would have to malfunction. So we can write that as a probability of A intersect B, right? Because the probability that A will malfunction intersected with the probability that B will malfunction if we assume that it is two are independent events, then we have the probability that A will malfunction, which is 0.08, and we'll multiply that times the probability that B will malfunction, which is 0.12. I just converted the percentages to decimals. So 0.08 times 0.12 equals 0.0096. Okay. Determine the probability that on any one day both machines will work effectively. So here we would want the probability that A works and the probability that B works. So those would be like the opposite. I think a better way to write that is A prime and B prime, right? So the probability of A prime times the probability of B prime. So these would be the inverses, right? It'd be 1 minus the probability of A times 1 minus the probability of B, which would be 0.92 times 0.88. Let's see what that is. 0.92, 0.88. When I get decimals, I go ahead and multiply it all out, right? If I have fractions, usually I just leave it in a reduced fraction. Kind of a good rule of thumb. Number 5, 2 marksmen fire at a target simultaneously. GD hits the target 70% of the time, and Benita hits it 80% of the time. Determine the probability that they both hit the target. Okay, so again, the probability that GD hits and the probability that Benita hits is equal to the probability that GD hits times the probability that Benita hits, assuming that they're independent. So that would, they both hit the target would be 0.7 times 0.8. I'm converting the percentage into decimals. That would give me 0.56. That would be A. What about B? They both missed the target. So that would be probability of not J intersected with the probability of not B, which is equal to the probability of not J times the probability of not B, which is equal to 1 minus 0.7, 0.3, times 1 minus 0.8, which is 0.2. And we're left with 0.6. Okay. C. GD hits, but Benita misses. So GD hits, Benita misses. So it's going to be probability of GD times the probability of Benita misses. So probability that GD hits, remember, is 0.7. Probability that Benita misses is 0.2. So that would be 0.14. Okay, last one, D. Benita hits, but GD misses. So probability of Benita hits, but GD misses is going to be equal to the probability of Benita times the probability of, I forget what we call that, J dashed. So that would be probability of B is 0.8. The probability of GD misses is 0.3. So that would be 0.24. Okay. Dependent, not independent events affect the probability of one another. Okay. In the case of dependent events, P probability of A then B. Notice it's not A and B, it's A then B. So like it makes it sound more like A happens, then B is going to happen. So it's like kind of affecting it. So that would be equal to the probability of A times the probability of B given that A has occurred. Okay, so A happens first, then the affects the probability of B, so you're adjusting. It's not probability of B, it's probability of B given that A has happened. Okay. Number 1. A bin contains 12 identically shaped chocolates, of which 8 are strawberry creams. If 3 chocolates are selected from the bin, determine the probability that they are all strawberry creams, none are strawberry creams. Okay. So drawing 3 chocolates simultaneously implies that there is no replacement. What do we mean by that? If you're drawing things out, and you draw 1 out of 10 items, then you're going to have 9 left, right? The second item you're drawing out of a denominator of 9. The third item you're going to draw out of a denominator of 8. So like every time the probability is going to be a little bit different because the composition of the bin is going to be different, right? So let's walk through this. So so you have 12 at the beginning. You have 12 chocolates, right? And then you're going to have 8 strawberry within the 12 chocolates. Okay, 8 strawberry, 12 chocolates. If 3 chocolates are selected simultaneously, determine the probability that they are all strawberries. Okay, so even though you're selecting them simultaneously, we need to write the equation as if we drew them out one at a time. So the first one, the probability that it was chocolate, and we're going to multiply all these probabilities together. The first probability is going to be 8 over 12 because you had 8 strawberries taken out of 12, right? The next one you took out is going to be a 7 out of 11 chance, right? And then last of all, it's going to be a 6 out of a 10 chance. Every time there's 1 less in the denominator, and there's 1 less strawberry cream because every time you're selecting the strawberry cream. So that's for A, and let's multiply that out into a decimal. So the numerator is 336. The denominator is going to be, you know, like this really big number, but the answer is going to be 0.255. Okay, so that's the probability that they're all strawberry creams. What is the probability that none are strawberry creams? Okay, so this would be kind of the opposite. The first draw, if it's not going to be a strawberry cream, then there's 4 chocolates that are not strawberry cream, so you'd have to pick those 4 out of the 12. Then the next draw, you also want not strawberry cream, so there's only 3 left, and there's only 11 total left. And then finally, on the last draw, there's only 2 not strawberry creams left. You pick 2, and then it's out of a total of 10, right? So let's see, 4 times 3 times 2, divided by 12, divided by 11, divided by 10. So the answer is 0.0182. Okay. A lottery has 100 tickets which are placed in a barrel. 3 tickets are drawn at random from the barrel without replacement to decide 3 prizes. Again, without replacement, that means you're taking things out, you're not putting it back, so every time the probability changes slightly for the next step, meaning that the probabilities are dependent. Okay? So a lottery has 100 tickets which are placed in a barrel. 3 tickets are drawn at random from the barrel without replacement to decide 3 prizes. If John has 3 tickets in the lottery, determine his probability of winning first prize, first and second prize, all 3 prizes. Okay. It doesn't really say what order they're drawing the tickets. So let's assume that the first draw is first prize, the second draw is second prize, and the third draw is third prize, although it doesn't really say. It could be third, second, first. But since they didn't say it, let's assume it was first, second, third. Okay? So what's the probability that John is going to win first prize? Well, he only has 3 tickets in the 100, so to win first prize, he would have to have his 3 tickets drawn in the first draw out of 100. What is the probability that he's going to win the first and the second prize? Then he would have to have a 3 in 100 chance of getting the first ticket drawn. The second ticket, which would be multiplied times that, it would be the probability of that he would get 2 tickets out of 99, right? And so that would be for B. We could write that as 6 over 9900. All right. And C, what's the probability that he wins all 3 prizes? So that would be 3 over 100 times 2 over 99 times 1 over 98. Okay, and let's see, that would be 6 divided by 100 divided by 99 divided by 98. Really small number. 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. 6, 1. Okay. Last of all, none of the prize. What's the probability he wins nothing? So in the first try, it would be 97 tickets that he would not win out of 100. On the second one, he still has 3 left in the barrel. There's only 99 tickets left in the barrel, so that would be 96 out of 99. And then on the last draw, there was a total of 98 tickets in the barrel, and 95 of them are not his. So let's see, 97 times 96 times 95 divided by 100 divided by 99 divided by 98 gives us 0.912. Okay, so that's the probability that he wins nothing. All right, and that is the end of page 8.